The second example we want to solve it today is example 7.12 on page 169. A 1 kilogram block moves with a speed of 10 meters per second. A 1 kilogram block moves with a speed of 10 meters per second and strikes a spring that has a spring constant K of 25 Newton per meter. Determine the maximum compression of the spring. Okay, girls, focus to understand this question. Here is what we have: a moving block. So the block here at the beginning, what it has? Kinetic energy. They didn't say released block. They said a block moving with a 10 meters per second. Though the block is coming with an initial speed of 10 meters per second coming toward the spring. Now, before the block reaches the spring and the block is moving, the spring, what is the compression of it? Is it compressed? It's not compressed, it's at rest. It is at rest. So X initial, do you remember the X for a spring? It is the amount that the spring has compressed or stretched. Here in this case, before the block reaches it, what it equals? 0. So here X initial equals 0 because the spring is at rest, is not moving. Good? Now what happened? After the block reaches the spring, what will happen? The block will compress the spring. Then the spring will send the block back again, right? So they said find the maximum compression of the spring. Now girls, at the maximum compression of the spring, what will happen to the motion of the block? The block will stop. You imagine with me, here's the block, it's moving, will compress at the point where the spring compresses the maximum. It is the point where the spring will push the block back again. So at this moment, you know it's the same as what? You remember in vertical motion when we talked about the maximum height? Here is the same. So now in your book, underline in the question, the sentence, find the maximum compression of the spring. It means the same as maximum height in vertical motion, for example. So what does it mean? It means that V final here equals 0. Okay? This is why V final for the block here is 0. Let's start solving the question. Here they didn't mention that we have friction, so we're talking about conservative forces. So we are going to use what? Mechanical energy initial equals mechanical energy final. Mechanical energy initial, I have kinetic energy initial. Here we are not talking about gravitational potential energy. We are talking about elastic potential energy. Initial equals kinetic energy final plus elastic potential energy final. Let's see what we are going to substitute here. First of all, before we substitute, what we're going to cancel? Now, kinetic energy initial, for sure it's not 0 because the block was moving with 10 meters per second. Elastic potential energy initial of the spring before the block reaches it, we said it is 0 because the spring is at rest, equilibrium position. No compression, no stretch. No, it's not compressed, it's not stretched. Kinetic energy final, we said at the maximum compression of the spring, kinetic energy final 0 because V is 0. Elastic potential energy final, for sure it's not 0 because it is compressed. So half mv final, initial square equals half kx final square. Half mv initial, half times 1, the mass is 1, and v initial square 10 square equals half, and k spring constant is given 25 times x final square. After you substitute and solve, you will find that x final equals 2 meters. So this is the maximum compression of the spring.